Welcome, and this time I'm going to I'm going to explain about the concepts of polymorphism inside object-oriented programming. This one is the fourth and the last feature of object-oriented programming. It is very difficult feature, and for polymorphism, it means same thing, okay, the same thing, but will behave differently, okay, in different situations. And for polymorphism, normally they divide it into two types, which is the static polymorphism. For static polymorphism, it is actually using method overloading. And another one is dynamic polymorphism, polymorphism, which is the method overriding. Okay, which is method overriding. And method overriding. Why do they call them static? Why do they call them dynamic? Let's just start with what is method overloading and what is method overriding as well. Method overloading. The first one is method overloading. The same methods, okay, with the same method and in the same class will behave differently, okay, based on in different situations. Let's just assume, let's just make an example, which is a person, okay, okay, a person. Let me just make a person can do math with the same method, which is to add, okay, but then the person can add two integer number in the x and y. Okay, the person can also use the same method with to add and return an integer int. The person can also add, instead of add two integers, can also add int x, int y, and int g. So instead of adding two integers, it can also add three integers. Okay, so this behavior won't behave differently. If you input two integers, it's going to call this add method. If you input three integers, it's going to call this add method. The same person can also add two string x, string y, and return its two string values inside in forms of integer numbers in form of string. If you input two string, it can also add the two string and return you the integer values of this additional thing. Okay, so anyway, the method of loading is not the same methods, but in different situations, which means in different cases of input numbers of input parameters, different numbers of input parameters, or difference of the input data type. It's going to behave differently, but the same add methods. Okay, same add method. So just to conclude on this one, the way for us to overload a method is by specifying different numbers of input parameter. Let's say instead of two input parameters, you're going to input three of them. Or you can overload a method by specify different input data type, okay, input parameter data type, data types. Let's say instead of inputting integer, you're going to specify string over there, or a combination, or combinations of the above two of the two. Okay, means both different numbers of data type, different also in data types. Okay, you don't say like int add string x, then int y, then int b, then int c, so on and so forth. Okay, so different numbers of parameters and different data type. But remember the way to not overloading is that if you only change the return data type. Okay, let's say you say that it's going to return string add int x int y. This one is not method overloading, because if you input two integer numbers, okay, compiler will not know where to call. It's gonna call this or it's gonna call this. It will not know. Okay, so changing the return type is not sufficient to be called as method overloading. So the way for it to overload methods is this. Okay, again, because let's say if you overload it by specify string add int x int y, then later on you're gonna call them like add 10 20, then it will not know which method to be called, add or this add or this add. It will not know. Okay, that's why. And this method overloading is called the static polymorphism, because this 1 method, 2 method, 3, 4, 5 methods are going to be created automatically at compile time, and it's there. Okay, that's why it's called static. Okay, and then right now we move to the dynamic one, which is at runtime, not at the compile time, which is called method overloading. Okay, for method overriding. Method overriding is applied in the case of inheritance, when the child class is going to re-implement. Okay, if the child class need to, or if the subtype need to just absolutely inherit everything from supertype without the ability of modifying some behaviors, this one is not good. Okay, without ability to customize the behaviors to fit its special type, it is not good. Okay, it is not good. Let's just give an example. Which is in this case. I think you already understand the case of the lecturer is also a person, the student is also the person with the special characteristics, which is the department, and this one, the student with the special characteristics, which is the class. Okay. However, the lecturer is a person and the student is a person. The lecturer extends a person and the student extends a person too. Okay. But then, which means the lecturer inherited the eat and the work method of the person. The student also inherited the eat and the work of the person. However, it doesn't mean that the lecturer must absolutely inherit everything from the person without ability to modify it. It's not going to be flexible. In this case, let's say the lecturer is going to eat the same way that the person eats. But if you tell the lecturer to work, it's not just working like this one. It should be teaching, because the lecturer is special type of the person. It's not just working in general, but the lecturer must be able to work but as teaching. Similarly, the lecturer inherited every of the characteristics as well as the behaviors of the person, but for the work method, okay, it's not working as a person, normal person. But when you tell the student to work, okay, it should be like, instead of work normally, it should be like studying. Okay, so the case is like this one. So for the normal person, if you call to the work methods, it is working. But for eat, the lecturer and the student, I think they're just eating the same way as a person eat. So you don't have to modify the eat method. But for the work methods, a normal person is shown as working. Okay, and by default, if the student just simply inherits from that one is working too, but you don't want so. You want the student to, instead of showing I'm working, the person should show like I'm studying. Similarly, the lecturer, instead of showing I'm working, if you tell the lecturer to work, it should show I'm teaching. Which means we must be able to override the methods, okay, work of the lecturer to be different from the method work of the person. We just not just simply inherit it absolutely 100% from the person, like the eat one. Why? Because the work method of the lecturer should behave differently, okay, and the work method of the student should behave differently comparing to the work method of the person, and this one is called method. This one is called method over writing. Okay, you re-implement the work method. Okay, which is the work method that you inherited from the super type. Okay, and one more point inside this method of writing or polymorphism thing is you can use. Okay, so you already explained about method over writing, which is you can re-implement the method that you inherited from the base class in order to fit the new behavior of the new or the special or the subtype. Okay, subtypes. In order to override it, just rewrite the method with the same signature there. And one more special point inside the polymorphism, which is you can use the pointer of the supertype to store or to point to object of the subtype. Let's say you can declare person P, and you're gonna say P equal to new lecturer, which is fine. Okay, P new lecturer, which is fine. Okay, so this person P equal to new lecturer. New lecturer is object of type lecturer and can be stored inside the pointer P. So because P is the super type of the lecturer, but you cannot do the another ways around. Cannot do the other way around. Let's say you cannot say lecturer L, then you say L equal to new persons. Why? Because the lecturer is a person, but not every person is a lecturer. Not every person is a lecturer. Okay, that's why you cannot do this way. You cannot do this way. Okay, you cannot do this way. Just you're gonna say that my husband is a lecturer. Is fine, but you cannot say any lecturer is my husband. It's not right. Okay, it is the same thing here. Okay, the lecturer is a person is fine, but you cannot say a person is a lecturer. Okay, because not every person is a lecturer, but every lecturer is a person. That's why you can do this. And in this case, if you take P dot work, it is going to call to the work method of the lecturer. Okay, it's going to call to the work method of the lecturer, not of the person. So it's gonna show I'm working instead of showing. It's gonna show I'm teaching instead of showing I'm working. Okay, and you can, however, you can only call to the behaviors of the person for this lecturer. You cannot call to the behavior of the lecturer. Means a method for the special method for the lecturer. You cannot call them because it's not available for the person. Okay, but if it works, it's gonna work like the lecturer. Okay, that's why it's called polymorphism, because the same work method. Let me just say I'm declare person P1 equal to new persons. Okay, and you do P1 dot work here. Okay, this one is going to give the result is I'm working, which is the working method of the person. Then you can take that P1 and you assign it to a new object, which is a lecturer. In this case, P1 is acting as a lecturer, and if you call P1 dot work, it is not showing I'm working anymore. It's showing you I'm teaching, which is the method of which is the method work of the lecturer. You already overridden. Okay, you already overridden. That's why the same method in different situations is going to act differently. Okay, that's why it's called polymorphism. Okay. Okay, and next part I'm going to use some code in order to demonstrate about this one.